colleagues. First of all, I would like to thank the organizing committee for the possibility to present this innovative composting solution, which was made in our company Alpa Green. I will make a short introduction and all the description of technological process except the financials. I'm sure not everybody knows you well, so I would like to introduce myself. I came to the field of agriculture from medicine. I am a neurologist, physician, and maybe 20 years ago, I have noticed that Homo and humus are the very similar world, and I switched to humus because our modern medicine only about 10% can influence the health of people, and about 30% is influenced by environment and especially soil. Next 40% is influenced by our way of living and food. So food and soil decide 70% of our health. So it's really very important topic, and I'm very thankful to everybody who are making our planet better place to live with better soil. I started this activities in the United States together with my colleagues, and then team in Lithuania, and in last 4 years it was developed in-vessel composting equipment, which can be used in waste management and agriculture. We call this technology robotic bioreactor organic waste management. Why robotic? About 100 years ago, people invented a name robot, and it came from Czech word robot. Nobody wanted to work hard. Everybody wanted that robots make the job. And the robots came not from scientific world, but from literature. And this is how the first robot in the world looked like. Our robot is very different. It's quite a big machine. The biggest one is 4 meters by 18 meters. This is the size of man, human. And actually, when you look, it's a quite simple machine. It has in-feed conveyor, where you put waste, and out-feed conveyor, where you get fertilizer. So typical circular economy solution. Waste in, fertilizer out. From waste, you make product. This is how it works.
Using artificial processing the process of breaking down for that moves the states of the Valdas system operated by a single person divided by the condition. That all to be possible. It's great to see results. AI really software optimizes the whole consumer production. It's not the process of what automatically a robotic insurance. And of course, out of the grants, 4 grants, 6 grants, 2 grants, and
So, dear colleagues, this bioreactor, as you saw in the movie, it's from the first view, it's a simple machine. It's a big rotating drum on the wheels, and it has in-feed conveyor and out-feed conveyor. When organic waste enter the cylinder, it's the odorless process, and because of temperature, it's free of weed seeds, free on infection agents, and it's humidity control. So you can produce exactly in the last end very, very stable product. The size of machine can be from 2 meters to 3 meters to 18 meters. Let's say from 130 cubic meters to 10 cubic meters. So it can use in a very, very wide fields. And the drum is filled 70%. So each day you can fill about 100 tons, 30 tons, 30 tons, 30 tons, about 100 tons of waste into the robotic bioreactor. This is a technological review to understand how it works. When the raw material waste mixed is going to the in-feed conveyor, then it's enter the drum. And of course, exothermic process, composting temperature is coming up. And there is ventilation where we can follow the humidity, the amount of ammonia, amount of methane, amount of mercaptan, different gases, sensors can be installed as much as we need to control. And in the last end, we are receiving almost all very stable products with stable humidity state, but of course, this is not the final compost. This is the compost need to go through the maturation phase. And it's very good that this machine is consuming only 9 kilowatts of electricity. So the process is exothermic and you get a lot of heat and you don't need electricity to run it. This is prognosis in computer, what the temperatures you can get inside. It can go in 1-2 days up to 75 degrees. If you want to make more, there are some kind of thermophilic bacteria, and the temperature now would be increased 90 degrees and more. But then the temperature is coming down and the mesophilic bacteria are recovering. It's very interesting that during the rotation, the granulation is going on inside the drum. the compost inside the drum is forming small granules, which is very easy to use for farmers in their farms and lands. According to EU regulation, fertilizing products must go through 70 degrees more at least 3 days. So all these requirements are fulfilled. 3 days can be composting material in the drum with the temperature 70 degrees. And we always get, of course, depending a little bit from the waste, but we always get something a little bit more than 2.5% of total nitrogen in the final compost, and we can call this compost then fertilizer, organic fertilizer, not compost anymore. So with this bioreactor, we declare that you can produce from waste fertilizer, not compost, and of course fertilizer is much more expensive than compost to compare. Which is a little bit bad news that you need peripheral equipment. It's not so easy just to throw in the bioreactor organic waste. Before the bioreactor, you must have something similar like biogas station, mixer, shredder, depending on the raw material, and it must be mixed in some proportions. These proportions are very easy proportions, the same what you need for composting. Carbon to nitrogen ratio, moisture content. Moisture content is very critical because if it is more than 65%, oxygen cannot reach composting molecules, and then you can get anaerobic process. It's of course app applications to follow how this machine is working. But before making compost, we opened, I think, the first laboratory in Lithuania. We opened it in ECONUT for investigation of composting potential. We installed the tubes where we put composting materials and put thermometer. Very easy test, but very valuable. Let's say we put materials which seems to be not good for composting, like blood, sludge, feces, poultry manure, mixed everything, and we saw that temperature has risen more than 70 degrees. It means that this mixture was composting extremely good, and in a few days we got almost fully composted product just in the delivered tubes. From 2020, we made such experiments in Sweden together with company Valdas, and they too were performing these tests of composting potential before making the composting. And two, it's very important to see what is composting potential, how self increasing of temperatures going on in the compost. What are applications of this machine? I think it can be installed in any kind of industry or municipality waste area where we need to manage organic waste. Agriculture, and in Arab Emirates was a request for carcass composting, forestry, kitchen, almost all areas where organic waste would be found. End product compost, I think everybody knows where it can be used. It's very valuable product, but this product I want to once more to tell that with the help of bioreactor, you can get not just the usual compost, you can get organic fertilizer with a higher total amount of nitrogen and other nutrients in the final product. It's of course a little bit more commercial things, what is advanced for different composting systems. The production of this machine is going in Lithuania, in Astra, very good quality factory in Alytus, and we are making now the development, and we got new support for the development of this machine. If compare inverter robotic bioreactors with other fields, how organic waste can be recycled, I think it's the most efficient solution. It's a little bit competing maybe with biogas, but in the end of biogas, you have digestate, which is doubtfully it's really fertilizer or it's waste. And now the most advanced systems after biogas production is digestate. What is left is going to composting bioreactor. This year, together with Astra producer, we got €500,000 for the development how phosphogypsum can be used in the composting. Because when you make composting in bioreactor, you can use up to 10% of phosphogypsum like a bulking material to make the compost better quality. As I told, this in-vessel composting is very good advanced thing to use together with biogas production, because when you have digestate, you can separate the solid fraction and let it through composting. Then it's much better for plants and for. So in the end, I would like to tell that this bioreactors, it's like a bridge and closing loop to restore ecosystems, to generate local business opportunities and transform soil quality. If we use bioreactors, we can control composting process and then ammonia evaporation and ammonia that going to the seawater is really under control. So this is shortly about this new technology. We like it very much because it's really from medical field looks very healthy, protects and soil from weeds and from microbes, and it's fully controlled process. You don't need to hesitate. Was temperature right, not right? Everything is registered and the emissions are controlled. And even we call this machine carbon-free emission machine because it's only CO2 is only emitted in the natural proportions. You don't need to produce anything, let's say, or use any kind of other sources of energy. Thank you very much, and sorry for some technical things. These computers those are not very friendly with other systems, so I really apologize. But these movies I want to have in extremely good quality, but yes, it happened how it happened. So thank you so much.
Somebody from the online participants and here have short questions. Please, you're welcome to ask. Use the opportunity.
Didn't put one point, maybe I just missed it. Is such a robot already existing under development? Because what we have seen are just images.
Yes, this in-vessel composting rotating bioreactors, aerobic, these systems are about 25 years in the market. So it's not a new system, but it's only new. What about robotics? Yeah. We installed a lot of robotic things, and now the first machine is in Alytus in construction stage. It never was used in the real environment, but it's the same like bicycle. If a quad drive, it will rotate, it will make, but with such extra equipment and the robotic set of mind that it must be really, it's just enough one man who will load this machine 30 tons once a day, and all the rest the machine must make by itself, and I'm sure it will make it.
Okay. So it's under development and the first will be installed
That's
soon.
very soon.
Maybe a couple of months to get rid of all the child diseases.
Yes, and let's say when it's new machine, our farmers and waste managers are very conservative. They want to see the machine in action. And we have challenged really that this machine we cannot install in our office. We must find partner who would like to use this machine. We cannot show it like in Senate Hall, installed in some real location.
Because as a leader of the waste management in Lithuania.
Thank you. This producer is very good. It's really more than 100 years and robotic welding, everything, very good quality product.
We are tentative about the emission, but this robotics, how is understand that there is no any emission.
Now it is emission, but emissions are natural. Let's say you don't need the extra fuel burn or so to this emission, like humans too making CO2 emissions, but it's natural emissions. So if you're making only natural emissions, not using any carbon sources from extra, it can be called carbon neutral production. It's not just zero emissions, it's natural emission. Yeah.
But it's CO2 emission is very, very.
But it's really very natural, as it must be. Other thing is, yeah.
But what is the level of emission?
Yeah. This I can check and come back to you exactly, because I cannot say exactly. No, but like physician, I can say that ammonia emissions is even more harmful for people than CO2 emissions, because ammonia emissions there for making aerosols, and these aerosols then the small particles, you have a lot of lung diseases, different diseases. Sorry to switch to my field where I better, but it's really very good that it's stopping this leaking of nitrogen to the seas, because it's closed, and to evaporation of nitrogen ammonia, because it is enclosed ground, and then emissions are the minimal what can be, and ammonia and nitrogen is fixed inside, so you always get much higher concentrations of total nitrogen in the end product to compare with the natural composting, which maybe 50% of ammonia going to the fire or to the.
Accept from the air as well.
Any more questions? Please.
This is model is totally on AI based model. So can you control or everything like pH and some valuation in some of kind of nutrients and some sideborne pathogens are also incorporated in the stems and leaves and the portion you're using for the composting of biofertilizer? Can you manage and control all these aspects?
It's a little bit like cake and oven. What you mix in the beginning, such product you will have. So you must be careful with mixing, not very careful, but at least careful to mixing the right proportion of nitrogen and carbon in the beginning. And other nutrients, they will not disappear. It's very important that in the last end you will get nutrients in the form like nature created. If you have fertilizer, you have very high concentrations, and sometimes it's toxic to plants. When you produce from natural waste, you will get natural proportions. And sometimes the proportions are more important than the amount. So I think that it's very valuable thing that you always get a little bit more than 2.5%, and you can call it total nitrogen. You can call it fertilizer, and that all nutrients are in the, let's say, right proportions. It's enough to have deficiency of one nutrient like selenium or something like this, and all the system will not work. Nutrients must be not pure, but in natural proportions, in my opinion.